How can a shaft fail without ever being overloaded? Most people assume a shaft only fails when it's overloaded. In truth, it can begin to fail before it ever transmits a single unit of power. When a shaft is supported by two bearings, the system is statically determinate, and the shaft aligns itself naturally. But the moment you introduce a third support or a gearbox carrying its own bearings, the system becomes statically indeterminate. If those supports aren't perfectly coaxial, the shaft has no alternative but to flex in order to seat itself. That subtle deformation gives rise to a permanent bending stress. There is no universal tolerance for it. It hinges on the length, the diameter, and the material. A short, stout shaft will tolerate far less misalignment than a long, slender one. Once the shaft begins to rotate, that bending remains fixed in space, yet the material swings from tension to compression with every single revolution. At 1,500 revolutions per minute, that amounts to 90,000 fatigue cycles per hour before the working load even enters the equation. In a finite element study on a mining shaft, a misalignment of merely 10 thousandths of an inch was enough to trigger a critical fatigue zone. Upgrading the material or shot peening extends service life, yet none of these enhancements can undo the effect of poor alignment. Geometry still prevails. This is why, in mining repair, the objective is not simply to machine a hole. The true objective is to restore the center line through precision metrology. The takeaway is straightforward. A shaft often fails not because it worked too hard, but because it was mounted misaligned from the very first day.